Hello, I'm Anna Mackay and this video is on increasing and decreasing functions in the applied calculus section. So looking at our graph here, we've got different sections of the graph and thinking about it for f of x, thinking about when is it increasing? So when are we going uphill essentially? So if you had to walk along this curve, well, from between here and here, you would be increasing. Let's just call them A and B. I'll anticipate C over there. And any other time that you would have to be walking uphill? Well, yes, from C onwards. So if the function f of x is increasing, it means the derivative f dashed of x is positive. And for the decreasing sections, so thinking about where the function is downhill, the derivative f dashed of x will be negative. And there's another section over here. You would have practiced that in the past, in last year, but let's do some examples now. All right, first of all, a question where for the function y is equal to that, we're already given the derivative, just to save us some time. So first of all, we want to draw a sign diagram for f dashed of x, or dy by dx. So to do that, you need to consider when that first derivative is equal to 0. So when f dashed of x is equal to 0. So we will put that whole function of the derivative equal to 0 and think about what we do. So when it's a fraction like that, you're going to have some vertical asymptotes. But first of all, the numerator, let's consider that when that is equal to 0. So we would have when negative 2x plus 8 is equal to 0. I should put this whole thing equal to 0 there. Solving for x, whenever you get one of these. So we've got x is equal to 4, so that's one of our critical values. And then vertical asymptotes will come when the denominator is equal to 0. So a vertical asymptote, we are putting the denominator equal to 0. And solving for x, we get 1. So drawing a sign diagram, obviously using a ruler so it's all nice and straight. This is a sign diagram for f dashed of x. And you put on those critical values. We have x is equal to 1 and 4. However, because 1 is a vertical asymptote, we represent that by a dashed line instead. So now we have to work out, well, okay, these is where critical values, that's where it's going to change possibly from increasing to decreasing, uphill to downhill. But how do we know if it's going to be uphill or downhill there? We'll create a visual for yourself. So get your graphics calculators out and let's have a look what the function, the original function, looked like, where it's uphill and where it's downhill. So I'll just go across to my emulator. Here's one I've prepared earlier. Here was our function, our y equals function, and I've typed that in already. So let's graph that. Here's what I prepared earlier. So our critical values were 1 and 4. Now let's having a look to the going from the left of the function. Going along this line, it would be downhill up until the point of 1. Now you can't see all of that on the screen. So to the left of 1, we would have negative because we're going downhill. After that, we are going uphill, and our previous value told us that at 4 something was going to change. It's a bit hard to tell there because it looks like it's horizontal. So how are we going to check? Well, if you have your derivative turned on, so in shift setup, your derivative is on. On that graph, let's trace a point. So we know that anything to the left of 1 is going to have a negative f dashed of x value, or dy by dx. So let's pick negative 2 here, negative 2. Now have a look. The dy by dx value is a negative number. So that confirms what we know, that it's going downhill, so the derivative is negative. Next, between 1 and 4, and sorry, that critical value was a vertical asymptote that we were talking about. Between 1 and 4, let's pick a number, let's pick 2. Now, our dy by dx is a positive number, 4 is positive, so we're uphill. So let's pick a number after positive 4, let's pick 5 and see what we get. our derivative, dy by dx, is a negative number, so that actually means that that's going downhill again. So our derivative is negative. So let's fill in our sign diagram then. We had negative, positive, negative. Obviously you've still got yours drawn. We've got 1 and 4, negative, positive, negative for our sign diagram. Next one. We have to do this all ourselves now. So find the intervals where the following function is increasing or decreasing. So in calculus, when in doubt, differentiate. So bringing down the powers, plus 6x. Okay, you know that for these questions you're probably going to have to go on and factorise them, so you can factorise at this point if you like. And we're interested when f dashed of x is equal to 0. So that's when it's going to change from increasing to decreasing. So if we put that derivative equal to 0 and solve for x, we will find that our values are 0 and positive 2. So on our sign diagram, they're going to be our values of interest. So for this is f dashed of x for 0 and 2. But again, how do you know where they're positive, where they're negative? Create a visual for yourself. So, oops, I meant to go to my emulator and graph the second graph. Here is it written here. So let's type that in. Negative x cubed plus 3x squared plus 5. I'll do a standard window and graph that. Okay, so our values were 0 and 2, where there was going to be some change, and it's downhill first, then uphill, then down. So negative, positive, negative. So we'll go back and redo that sign diagram. Negative, positive, negative. Obviously I've lost that here. Negative, positive, negative before I forget, and our values were 0 and 2. But we don't have to just do the sign diagram, we have to state the intervals where it's increasing or decreasing for the function. So let's write that out. F of x is increasing. I'll get ahead of myself and write the other one too. Okay, so increasing, first of all, is when we have a positive sign there. So between 0 and 2, the function is increasing because the derivative is positive. So how we're writing that, it's for x between 0 and 2. And let's not get too caught up on whether or not they're equal to 0 or 2 right now. It doesn't really matter, but this is my preference to not put the equal to. And decreasing for x for values less than 0 and for values greater than 2. So writing that with interval notation, for x less than 0 and for x greater than 2. So that's how we answer these types of questions. We've got one more, a trig question. Now these will be right at the end of all the work that you're doing, but I wanted to show it to you now. So for cos x, to work out where it's increasing or decreasing, we need the derivative. So the derivative of cos of x is negative sine x. Now to find where it's increasing or decreasing, you put it equal to 0. So when is negative sine x equal to 0? Well, when sine of x is equal to 0. So thinking about your unit circle, when is sine of x equal to 0? Sine of x is the y coordinate. So when is the unit circle have a y coordinate of 0? So and that is when our angle is at 0, or over here we've got pi, or every multiple of pi. So for when x is 0 or pi. So they're going to be our values on our sign diagram, 0 and pi. But let's create a visual. Always use your graphics calculator. So back to your calculator, and the function was cos of x, and the window you want is for trigonometry, graphing cos. Now every dash on here is pi on 2. So here x is equal to 0, and we've got a critical value, so our tangent would be 0, slope of 0, and down here the second dash is pi, and that's where it's changing as well. So we've got a decreasing function between 0 and pi, and then increasing up until 2 pi. So let's draw that on our sine diagram back here now. Our sine diagram is, we mentioned 0 and pi. Between those two it was decreasing, so that's, we put a negative there. And then, well, where is it increasing? Well, it was between pi and then 2 pi. And then, as we know with periodic functions, they're just going to keep repeating. So there are two windows that we're interested in, and let's write that now. So f of x is increasing between pi and 2 pi. So for x is between pi and 2 pi, as we said, but not just those, for every multiple, every repetition of those between pi and 2 pi. And the way we notate that is adding on 2k pi to either side, 2k pi. And for the decreasing is decreasing, so between 0 and pi. So again, interval notation between 0 and pi, and adding on 2k pi. And an extra side note, that's where k belongs to the set of integers. If you've ever wondered why it's a z, it comes from the German word for Zahlen, which means number. Okay, that's the end of this video. If you liked it, give it a thumbs up and subscribe to the channel, and the next video will be called Stationary Points. Thank you.